Hi everyone, today we're going to be solving the 12th question from the May 2025 paper 1 time zone 1 of the IBDP Mathematics Analysis and Approaches higher level exam. So let's get started. Consider the family of functions fn x equals cosine nx, where x is a real number and n is a natural number. By writing cosine nx as cosine n minus 1x cosine x, show that. Okay, so essentially what's required for us to do here is we have to write cosine nx as this form and then perform a by parts substitution in order to get this part that we have here. So I've copied and pasted the question here to get a clearer look at the question. So when I write cosine nx as cosine n minus 1x cosine x, it is going to be very easy for me to do a substitution. I'm essentially going to call u cosine n minus 1x. I'm going to call dv cosine x dx. Then du is going to be, in this case, n minus 1 times cosine n minus 2, and then minus sine x. While this part here is going to be v equals sine x. And of course we know the by part substitution method. If I have an equation, that's going to be u times v minus v times du. So if I had to write it in that part, it's going to be cosine n minus 1x times sine x minus integral sine x times minus n minus 1, and then cosine n minus 2, then cosine n minus 2x, I'm sorry I forgot that, and sine x. So let's clear this up a little bit to make sure that it looks like this. Again, this part is already done, cosine n minus 1x sine x, and then I can take this part out because it's a constant out of the integral, and then the rest of the integral is going to look something like this. Cosine n minus 2x times sine squared x dx. So at this time I know that I have to write everything in terms of cosine x, and I know that sine squared x plus cosine squared x equals to 1, and you don't even have to write this down to know that sine squared x essentially equals 1 minus cosine squared x. So that is what I'm going to write in place of that. Cosine n minus sine x, cosine n minus x sine x minus n minus 1. And that is going to be, because this was minus n minus 1, if I take it out and like multiply it with this minus here, it's going to be plus n minus 1 cosine n minus 2x times 1 minus cosine squared x dx. And as this is clear, we can also write this as cosine n minus 1x sine x plus n minus 1, and I just basically throw this into this parenthesis that we have here. That is going to be cosine n minus 2x dx minus cosine nx dx. But of course I forgot to put this here too, so the only thing missing is I'm going to put an n minus 1 here too. So as you can see, this matches what we tried to achieve here, which is basically this formula that we have. And one thing that's very important to remember in these questions is you always have to look at the previous question. And question, I mean, for example, if you're looking at B, you can look at A, and if you're looking at C, you can take a look at A and B to understand what you have to do if you're confused, because IB questions make you achieve everything step by step. So what you're going to do in C is essentially what you've already done in A and B. So that's something that's important to consider. So now I have this one. Now the question asks me to show this equation that I had here, f and x, f base and x, in this form that we have here. So when you look at this, it is very clear that this whole equation that we found previously here is multiplied by 1 over n. And at first glance, you say, okay, there's something that I need to do in order to make sure that I'm somehow dividing this whole section by n. And if you take a closer look at the situation, you can see that this is integral cosine n minus 2x dx. And in order to achieve this side, you have to get rid of something at this side. And that is going to be this part right here. Because you realize that because this equals integral cosine x dx, if you throw this part into the left part of the equation that we have here, this is going to be n minus 1 cosine nx dx. And the rest I'm going to write as it is. Sorry, there's no integral here. Cosine n minus 1x sine x plus n minus 1 cosine n minus 2x dx. As you can see here, I can also write this part as cosine nx dx, but I'll have to throw this part here because this is essentially 1. The 1's go away. I am left with n integral cosine nx dx, which equals to cosine n minus 1x sine x plus n minus 1 cosine n minus 2x dx. As you can see here, in order to get rid of the n that I have here, I'll have to divide this side by n. And if I do that, what I'm going to be left with is what the question wanted me to find here. So 1 over n cosine n minus 1x sine x, again, as I've said. And then I divide this part by n minus 1 over n. Integral, this basically equals f sub n minus 2 x dx. So we're left with this part of the equation that was required for us to find. The C part is all about equations and calculation. And as I've said, all the IB sections that are within the questions require the reader to look at the previous sections that were achieved. So here, the cosine to the fourth power x dx within the integral is basically going to be what we have found here. So if I attempt to write it this way, I'm going to be left with the part that was required for us to do. So as you can see, cosine to the nth power x dx, it has transformed into cosine to the fourth power x dx. So I'm going to start with 1 over 4. Then I'm going to do cosine to the third power, cosine cubed x, sine x, and then 3 over 4. And this part is going to be f sub 2x dx. And this is basically going to mean cosine squared x dx. So we're going to write it in that way. And then this is going to be equal to cosine cubed x sine x. And I'm going to write 3 over 4 and open up a parenthesis because we're going to have to write this in a suitable way too. This is basically going to be, from the double angle identity, cosine 2x plus 1 over 2, right? But there's still an integral here. Cosine 2x plus 1 over 2 dx. And I'm going to continue 1 over 4 cosine cubed x sine x. It's always important to remember what you've written before and to make sure that you're not making any mistakes. Then I will be confidently able to say 3 over 8 cosine x sine x and 3x over 8. And the most important thing, you should not forget the c that we have here because it's another important mark that we have. So let's return to the basis of the question. And we have written it. You have to, I think, label what P, Q, and R are. The region R is enclosed by the graph of y equals cosine squared x and the x-axis where minus pi over 2, blah, 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 as shown in the following diagram. Okay, this is the y equals cosine squared x diagram that we have here. The region R is rotated by 2 pi radians around the x-axis, so this is important. The fact that it's rotated around the x-axis shows us that to calculate the volume, we're going to do dx, and then we're going to have to do y squared inside here. And y squared, of course, we're going to write in terms of this. Find the volume of the solid. So I'm not going to be doing the part E, so this is going to be our last section. So if I had to calculate the volume, this is obviously going to be pi integral cosine squared x squared and dx. So as I've said before, every section of IB questions are interconnected to each other. So that means that the fact that we are using pi integral cosine to the 4th power x dx is not a coincidence. It just means that the question previously made us calculate what integral cosine to the 4th power x dx is in order to purposefully help us in the section D for this question, for example. So this is basically going to be, and I'm not going to calculate it, but this is just going to show us that pi and our, I forgot its name, our limits is going to be minus pi over 2 and pi over 2 because that's what the region spans from, cosine to the 4th power x dx, and this is what we're going to have to calculate. And then alternatively, you can also do 2 pi 0 to pi over 2 cosine for x dx. And then all that's left for you to do is just to put the values inside these, and then the final answer that you should have gotten is going to be 3 pi squared over 8. So that was it for this question. Thank you everyone for watching, and if there are other questions, any other questions that you have about these solutions or any other questions that you couldn't understand and want me to solve, I'm always open to them. Thank you so much and wish you a healthy day.